In this video we will solve question number 38. Here f is a real function and g is also a real function, and fx and gx both are series, and x1 x2 x3 x4 are real number such that x1 is less than from 0 but greater than from x1 is less than from x2 but greater than from 0, and x3 is less than from x4 but greater than from 0. Okay, that means this is origin x equal to 0, and here is x1 and x2. x1 is less than from x2 but greater than from 0. Okay, and x3 may be less than from x1 or between x1 and x2, or x3 greater than x2. Okay, if x3 less than from x1, then x3 x4 may be between x1 and x2 or greater than from x2 x4. Okay, and if x3 is here between x1 and x2, then x4 will be here in this position or greater than from x2. Okay, if x3 greater than from x2, that means if x3 is here, then x4 will be in this position. Okay, and now fx1 equals to fx2 equal to 0, and fx not equal to 0 when x1 less than x less than x2. That means this curve will be like that. Okay, this curve will be like that, or this curve will be like that. Okay, and now this equation is called Bessel equation. Okay, and this equation is Bessel equation, and this is y equal to this is solution of this equation. Okay, this differential equation, and jn is this. And if you put n equals to 0 here, if you put n equals to 0 here, then n equals to 0, then j naught x is summation n equals to 0 to infinity. It's not n equal to 0, this is r equal to 0. Okay, so r equal to 0 to infinity minus 1 whole to the power r by here we put n equals to 0, so factorial r into 0 plus r factorial x by 2 whole to the power 0 plus 2r. Okay, so this equals to summation r equals to 0 to infinity minus 1 whole to the power r by factorial r into factorial r, that means factorial r whole square, and x by 2 whole to the power 2r. Okay, and this equals to summation, if you replace r by m, then m equals to 0 to infinity minus 1 whole to the power m by factorial m whole square into x by 2 whole to the power 2m. Okay, and this equals to summation m equal to 0 to infinity minus 1 whole to the power m into x to the power 2m by factorial m whole square into 2 to the power 2m. Okay, and this equals to fx. Okay, this is fx. Okay, and if you put here n equals to, if you put here n equals to 1, okay, then 1 minute, j suffix n x is summation r equals to 0 to infinity minus 1 whole to the power r by factorial r into n plus r factorial x by 2 whole to the power n plus 2r. Okay, and if you put n equals to 1, put n equals to 1, j suffix 1 x equals to summation r equals to 0 to infinity minus 1 whole to the power r by factorial r into 1 plus r factorial x by 2 whole to the power n plus 2r. Okay, and this equals to if you replace j1x, if you replace r by m, then m equals to 0 to infinity minus 1 whole to the power m by factorial m into m plus 1 factorial x by 2 whole to the power n plus 2m. Okay, and this is summation m equals to 0 to infinity minus 1 whole to the power m by factorial m plus 1 into 2 to the power, here we put n equals to 1, so this is 1 plus 2m, so 2 to the power 1 plus 2m uh, 1 minute. Yeah, and x to the power 1 plus 2m. Okay, and this equals to this x to the power 1 plus 2m, this equals to x to the power 1 into x to the power 2m. Okay, so j1x is equals to summation m equals to 0 to infinity, okay, and minus 1 whole to the power m into x to the power 2m by factorial m into factorial m plus 1 by 2 to the power m. Okay, and this is x, and from here by 2. So this equals to gx. which is given in this question. Gx equal to this. Okay, and the curve j naught x is this. This is the curve j naught x, and this yellow curve is j1x. j1x is gx, and j naught x is fx. Okay, and if you put x equal to 0 in fx, that means f0x. Okay, if you put x equal to 0, then if you put x equal to 0 here, summation this, if you put here x equal to 0, then it will be 1. That means f0 equal to 1. Okay, f0 equal to 1. If you put here, then it will give f0 equals to 1. So the point is 0, 1. This point is 0, 1. Okay, okay, this is fx and this is gx. Now in this question, fx1 equal to fx2 equal to 0. Suppose x1 is this and x2 is this. Okay, and at this point x1 and x2, fx is 0. Okay, and gx3 equal to gx4 equal to 0. So suppose x3 is this and x4 is this. Okay, now in first option, the function fx does not vanish anywhere in the interval x3 and x4. That means fx does not vanish between x3 and x4. Okay, that means fx not equals to 0 between x3 and x4. Between x3 and x4, fx is 0 at x equal to 2. So option A is incorrect. Okay, now in option B, the function f vanishes exactly 1 point once in the interval x3 and x4. Yes, it's true, because fx is 0 at x2, which is between x3 and x4. So option B is correct. Next, in option C, the function g does not vanish anywhere in the interval x1 and x2. Between x1 and x2, gx is vanish at x3. So option C is incorrect. And in option D, the function g vanishes exactly once in the interval x1 and x2. In between x1 and x2, g vanishes exactly 1 point x3. So option D is correct. Okay, so option B and D are correct options. Okay.